So what we're going to pick up next here with some different things involving functions has to do with what's known as a step function, also referred to as the greatest integer function. We're also going to look at how to graph what's known as a piecewise function. So what we're going to look at first here is the step function, otherwise known as the greatest integer function. That's this right here. So the greatest integer function, and this is how that is denoted, f of x equals, and it looks like you have double brackets around the value of x here. And whenever we put a number inside these double brackets, what we're basically looking for is what is the integer that is less than or equal to that given value. So I gave you some examples of this down here at the bottom. So if we're looking for what is the greatest integer function of -1, the answer to that would be -1 because of the equal to part in regards to this right here. Second one here, if you have the greatest integer function of -1/2. So anytime we're dealing with a value that is not a whole number, we're basically asking ourselves, what is the greatest integer that is less than that given value? So in this case, that would be -1. Same thing here with the third part. Greatest integer function of 1/10. What is the greatest integer that's less than 1/10? Well, that would be 0. And I'll show you a quick little thing you can do with these on the number line to make this easier to sort of visualize. And then if we had the greatest integer function of 1.5, what is the greatest integer that's less than 1.5? Well, that would be +1. So if I could exit out of here and just kind of go over with you real quick, just a visual of what we're talking about with this here. So if I kind of just pull this up and I just go to just a number line here. So I'm just going to kind of just draw myself a number line, and we're basically looking at something that's similar to those examples we just did. So if we had this, the greatest integer function of -1/2. So if you take a look at your number line here, here's -1, and here's -1/2. We would say maybe right about here. So what I'm essentially looking for when we're talking about values that are not integers is I'm basically, if you think of your number line, visually speaking here, I'm basically looking at what is the closest integer that would be to the left of that given value. So we're basically talking about that right there. Same kind of thing with one of the other ones we had, which was 1/10. So if I had this, okay, here's +1 over here. 1/10 would be, like maybe right about there. So if you had, once again, what is the integer that would be to the left of that value? So that would be 0. And then the same kind of thing if we had 1.5. Right, so here's 2. Right, here's 1.5. Right, so the integer that's to the left of 1.5 would be +1. So just something that you can kind of use just to sort of visualize what it is that we're looking at in terms of the greatest integer function. So if I come back to what we're going to basically do with this is talk about what the graph for this looks like. Okay, and here is just some of the characteristics of the greatest integer function. Come back to this here. So the domain for this is the set of all real numbers. The range for this, also the set of all real numbers. They both go from -infinity to +infinity. The graph has a y-intercept at 0, 0, right at the origin right here. And it has x-intercepts on the interval from 0 to 1, but not including 1. The graph is constant between each pair of consecutive integers, so you notice you have horizontal lines in between each pair of consecutive integers, and the graph jumps vertically 1 unit at each integer value. And we're going to talk about some different things with table of values to sort of illustrate that. So take a look at this here. So the question says just to evaluate the function when x equals -1, x equals 2, x equals 3 halves for the following function, greatest integer function of x plus 1. So if I start with this, x equals negative 1. So if I put a negative 1 in for x, and I do this here, so I have the greatest integer function of negative 1 plus 1. Okay, so the answer to this right here is going to be negative 1, and then plus 1 would be 0. So just remember that anytime we put a whole number in here, the answer to this is just what the value of the integer is. Okay, because that's the equal to part of less than or equal to in the definition for that there. So that's part A. For the second part, if I did when x is 2, so I'm going to do f of 2 here. So this is going to be the greatest integer function of 2 plus 1 at the end. So the answer to this is 2, and then plus the 1 would be 3. So that's the second part of that there. And then finally, the last part, if I do f of, let me just put this at the top here just so we know what we're talking about when x is 3 halves. So if I do f of 3 halves, this is going to be the greatest integer function of 3 halves plus 1 at the end. So remember, 3 halves is 1.5, so that is not an integer. So the greatest integer that's less than 1.5 would be positive 1. So the answer to this is 1 plus the 1 would equal 2. So just remember, when we're talking about 3 halves, right, we're basically talking about the greatest integer function of that would be the integer that's to the left of 3 halves, and that's why you get a 1 when you do that there. So that's just some different things in terms of substituting and evaluating involving the step function. If we're talking about the graph for this now, so a couple things to keep in mind with the graph, okay? If I could take you back to the shape of this here. So remember, it's called the step function because, if I kind of just drew some vertical lines here, the graph would look like a set of steps. So in terms of what I want to do as far as the graph for this, I'm going to get some points from an XY table to plot, and then we're going to sort of refer back to the original graph as far as how to fill in some other sort of points that are on the graph here. So first thing I'm going to do is I'm going to put a 0 in for x, and if I do this, if I do the greatest integer function of 0 plus 1, that has a value of 1. So 0, 1 is one of my points on the graph here. So then if I were to put a 1 in for x, and then I do the greatest integer function of 1 plus 1, the answer to this is 2. So 1, 2 would be another point on the graph. So one of the things to notice about the graph of this here is you have these horizontal lines that run in between two consecutive integers. So for instance, if I take a look at some values that are between 0 and 1, like let's say I did 1.1, and I did the greatest integer function of 1.1 plus 1. The answer to this part here is going to be 1 plus 1 would be 2. So you'd have another point that's on the same sort of vertical part of this, but once again, if I go over 1.1 and up 2, kind of in the same sort of spot there. And if I did 1.2, just notice the same kind of thing is going to happen here. If I put a 1.2 in here, plus 1, value once again is also 2. And that's going to continue on until I get to positive 2. Because when I put positive 2 in here, that's now going to make this 3. So another point on the graph is going to be here. So what I have on here, if you notice the steps, you have closed circles on the left side of each of these horizontal lines and an open circle on the right hand side. So what I'm going to do when I go to make this graph, I have a few closed circles here. So what I'm going to do here for this part, I'm going to put an open circle here and sort of connect it with some horizontal lines going across, and then I'm going to get a closed circle here, and same thing, I'm going to get a open circle on this side and connect those two circles with a horizontal line. Kind of tough to see here because my graph's a little bit tight, but the pattern that you're essentially looking to fill in is the same as what this is here. Closed circle on the left, open circle on the right, horizontal line that connects the two circles there. So that is the greatest integer function, otherwise known as the step function. So the other graph that we're going to get into looking at here is also what's known as a piecewise function. So we've done some different things with piecewise functions in regards to substituting and evaluating. What we're going to look at next is how to graph a piecewise function. So here is an example of a piecewise function, and what we've done with some different things with this has been some things with functional notation in regards to substituting and evaluating. So we haven't really done a whole lot with this as far as a graph goes. So what I'm basically going to get when I graph this is I'm going to get two different pieces to this graph. I'm going to get one that sort of comes from this piece here, and I'm going to get another part of the graph that's going to come from this piece here. And what I'm going to do for each one of these is I'm going to make an XY table. So I'm going to start with just this first piece, 2x plus 3 less than or equal to -1. And just keep in mind, we know that since this has a degree of 1, I know that this is going to be a straight line. So I can get away in terms of the number of points that I could use to make this graph. I can get away with 2 points here, and I always want to start, let me erase this piece here, I forgot to put the x in this here, so let me sort of take this away and get my x value in here. So this is when x is less than or equal to -1. So the first point that I always want to put in my XY table is whatever this value is here. So I'm going to put this -1 in first. And when I do 2 times -1 plus 3, I get +1. And that's one of the points that's going to go on the graph. And since in this particular instance x is less than or equal to -1, I'm going to put a closed circle on the graph when I do that. So I'm going to have a point that's going to go here, and it's going to be a closed circle because it's x is less than or equal to -1. So now I just need one more point, and I can connect those 2 points with a line. So the next number I want to put in for x, and just notice this condition that I have here at the end, I want to pick a number for x that is less than -1. So say if I put -2 in for x, and if I do 2 times -2 plus 3, it's a -2. This would be -1. So -2, -1 would be another point. So I'm going to go 2 to the left, down 1. I'm going to put a little point right here. And then all I want to do is I want to take this, and since it's a line, I just want to take the 2 points and connect them. So just notice that I'm not drawing this line through to the right side of that first point that I made, because this is just a line that I'm going to make for values of x that are less than or equal to -1. If x is greater than -1, that's this function that I'm going to graph here. So let me erase the table here, and I'm going to put this second piece into this. So let me get rid of this here. And I'm going to do the second part of this, which is -x plus 4 is greater than +1. So when I do this piece, -x plus 4 is when x is greater than +1. So this actually This should say -1 for these. No, that's not written in there, but that should be a -1 when I go to do those. So when I have my XY table here, and that should be a -1. So once again, I'm going to put a -1 in for X here. So when I put a -1 in for X, I have -1 plus 4, which when I work that out is going to be +5. So I have -1, +5, which would be a point that's right about here. But remember with this, I should sort of back that up a little bit. Remember with this, because I have X greater than -1 and not equal to -1, when I go to put this point on the graph, I actually want to make it an open circle and not a closed circle. So 1, 2, 3, 4. So I want to go open circle here instead of a closed circle. And that's basically just to sort of symbolize that this is not, X does not equal -1 for -X plus 4. So that's where the open circle comes from. So now I want to get one more point, because once again, this piece of the graph is also a straight line since it's has a degree of 1. So when I go to put another number in for X, I want to make this value greater than -1. So I'm going to put a 0 in here. And when I put a 0 in here, the answer to this is +4. So 0, 4 would be another point on the graph, which would be right about here. And then all I want to do once again is just connect those 2 points with a line. So I'm going to get something that kind of looks like this. And that is the 2 pieces of this graph here. So one of the things that I wanted to show you with each one of these graphs was how you can use your calculator to check these. So if I come back to the step function, the greatest integer function that we had, greatest integer function of X plus 1, if you take your calculators and you go to y equals, let me sort of clear this out here, and you go to math, and you go to number, and you go to number 5, and where it says integer, that's the greatest integer function. So if I put an X in there, and then I do a +1 at the end, and then let me zoom 6 this, you get something that looks like this here. So one of the things that your calculator is not going to draw for you when you do this is it's not going to have for you on here which side of the segments are closed circles, which side are the open circles. So you're going to have to know that from the original graph, which is what this sort of says here. So that's basically the one piece. And then if we look at the other example of the piecewise function. So in terms of putting this into your calculator, it's a little bit of a sort of a weird looking thing that you're going to have to do here. So if you take the first piece, 2x plus 3 is less than or equal to 1. If I go to y equals, I want to put first the function in parentheses, 2x plus 3, and then I want to put after that in its own parentheses the condition. X is, to get the less than or equal to sign, you have to put second and then math, which is the test screen. So I want to put in a 6 here for less than or equal to -1, and then plus, and then I'm going to put the second piece to this in, which is -x plus 4 is greater than 1. So I'm going to put in its own parentheses the function -x plus 4, and then the condition after that. So I got in its own parentheses, x is second math, greater than is 3. I'm going to put a -1 at the end there. And when I graph this, here's what you get. So keep in mind, similar to what I showed you with the step function in regards to your calculator, it's not going to give you open circles, closed circles on your graphs here. That's something you're going to have to know what to do with those based on the condition that it gives at the end of each function, but kind of gives you a pretty good indicator in terms of what your graph looks like and things like that. So that's basically how you use your calculator to do each one of those different types of graphs. And then the thing I just wanted to kind of finish up with you here, which was, here is a list of all the different functions that we've done over the last two lessons. So you have these two here, the two special types of linear functions. You have the constant function and you have the identity function. And then we have some things that we didn't really talk too much about, but you guys did a lot of work with last year, the absolute value function. And then you have here the square root function, which is sort of a hill shape. We have the quadratic function, which is a U shape. You have the cubic function, which is a chair shape. Then you have the reciprocal function, y equals 1 over x. And you have the two curves for each of those pieces there. And then you have the greatest integer function, which is otherwise known as the step function. So one of the things that you want to attempt to do with each one of these common functions, actually, you want to try to basically do three things with them. One is you want to make sure that you know the shape of each of the graphs, the name of each of the graphs, constant function, identity function, things like that, and the equation that's associated with those shapes and those names. So those are some things that you want to make sure that you, at some point in time through the process of what we're doing here, that you memorize those types of things, so that when we start to get into doing some different things next with transformations, you're not using too much brain power thinking about what the name of the different functions are, or what they look like on the graph, or what the equation is for each one of those. So a lot of what we're going to look at in the next set of notes is how we take each of these common functions and move them around on the graph, how we move them up and down, how we move them left and right, how we flip them over the x-axis, how we flip them over the y-axis, which is what's known as reflecting, and some different things that kind of go with some of those concepts there.